Okay, so welcome back. In this video, we're going to start talking about some excellent engineering tools. Now, when I say excellent, I mean very useful, can be annoying, but very, very useful. And this tool we're going to start out with is Microsoft Excel. Now, this probably applies to Libre Office or OpenOffice or any other spreadsheet you might use. But I want to get you familiar with some of the things you can do you might not be aware of. And here I've got a spreadsheet that I made in Excel that deals with complex numbers. And I can also do graphs. Here's another spreadsheet where I do graphs. This I use a lot. Like if I want to capture a waveform from a scope or a data acquisition unit, I get a CSV file, put it in here, and then plot it. Very useful. So you can do graphs. Again, I use that all the time. And then you can do some fancy graphs, like you do log-log graphs. Here I'm putting together another video on understanding inductors and measuring inductors with a signal generator. And this is very useful. You can figure out inductance values based on the results of the bench testing. So again, my experience with Excel is honestly that it's not really that well written, and I'm always scratching my head on how to do stuff. But the good thing about it is you can generate a spreadsheet. Like, for example, I've got a complex number spreadsheet, and you can put down all the stuff you need in order to calculate complex numbers, like if you want to multiply or divide or get the complex conjugate. You can put together a spreadsheet that's all ready to go. And in this case, all I have to do is enter the R and X, or real and imaginary components of two numbers, and it prints them out in complex form, and it tells me the magnitude, the angle, converts that to radians, and then it gives me the complex conjugate. It divides the two and gives me the real component and the imaginary component. So it's really nice. You can set everything up, and then if you need to do a calculation, just enter the numbers and it automatically calculates. Now, what I've got here on the right is some helpful tips on some of the functions you can use to do all of this, all right? And this isn't comprehensive, but it's most of the ones you're probably going to want to deal with. You can do conversion. For example, you use the degrees function and put in a number that's in radians, and it converts to degrees. And same thing for radians. And so, for example, I've got an angle here of 53 degrees. Let's convert that to radians. So I can go down to any cell here, and I do equals radians, and then I click on the number F4, and it converts that to 0.927 radians. And you can see that's the correct answer. So basically all you do is you put in an equal sign to tell it I've got an equation coming, and type in radians, give it a cell or a number. You can put in the number directly, and it will give you an answer. So really very useful. You can also do other types of conversions. Like if you want to convert 25 degrees centigrade to Fahrenheit, you can use this. Convert 25, C, F. And there is a whole list of different conversions you can do. And then complex numbers. For example, if I want to define a complex number in this cell, let's go to this cell, and I can say complex, and in parentheses, the R value, the X value, and then a quotes, I put a J if I want it to show up as a J. So equals complex 1, 1, J, and there you go. It's 1 plus 1J. Or I can change that to, go up here, change it to 2, and I've got 1 plus 2J. So now I've got a complex number in this cell, and I can go over to this cell, and I can figure out, for example, what's the magnitude and angle. So here's my complex number. If I want to get the magnitude, I use the IMABS function. So equals IMABS, and then I go over and I click on the cell that's got the complex number, parentheses, and that is a magnitude of 2.236068, all right? And then if I want the angle of this, I use the IM argument, and I do the same thing. Or if I've got a polar form, I've got a magnitude and angle, I do the real, IM real, and that IM is for imaginary. IM real, and you put in a complex number, and it gives you the real component. And IM imaginary gives the I or X component, okay? So really pretty straightforward. And generally what I do is I have cells in series. So for example, I have a number, and then I come out in the next cell, I calculate the magnitude, and then the angle, and then convert that to radians. So you can just go as much as you want. You can calculate as many things as you want. Now you can also do like division, and you don't just use a division sign, unfortunately. You use the IMDIV, and you put in A and B complex numbers, and it gives you the answer. For example, here I've got A over B. I've got this A, which is 3 plus J4, and B, 5 plus J6, and I divide them, and this gives me the real component of the divided value, all right? Or I can use the IM product of A and B. Or I can multiply more than 2. I can get the conjugate, IM conjugate, IM power. I can raise it to a power. And there's another one you're going to want to use, which is the round. And that rounds, like if you're doing a complex number, you may want to round it down so you don't have many digits, because it tends to, and this is one of the annoying features, it tends to give you many, many digits when you do complex numbers, so you may have to round it. So for example, I've got my 3 plus J4, 5 plus J6, and what I've done here is I have divided the two. And in order to do that, I get the IM real of the divided value, and I have to round that down to 2 digits. Otherwise, it gives me like 20 digits. And then I have the imaginary part of the divided value, and I round that down, and then I take those two and create a complex number, and that's the answer. Again, it's a bit annoying, but once you've got this done, you save this spreadsheet, and if you ever have to do complex numbers, you can come back and do it. Now, another thing you're going to want to do is, for example, if I have this complex B4 and C4. It takes these two values and converts them to a complex number. And I use this complex R, X, and J in quotes. If I want to copy that, what I do is I click on this, I hit Control C, and you can see I got a dancing box around it. Then what I do is I click off of that to deselect it, and then I can Control V and paste it. And now I've got that same formula, but it uses different values relative to, it thinks that these two are the two values. Again, kind of annoying. So you just fill in the correct values and you'll get the answer. So anyway, that's kind of just to get you familiar with the complex numbers. You may not have known about that. Now, I set up another spreadsheet. Now, again, what you might want to do is make a set of spreadsheets in one file that do things like complex numbers and graphs and those kinds of things. And just save that. And if you have to do those calculations, just open up the spreadsheet and pick which one you want to do, and you have it all set to go. And you can even have these notes here to tell you what to use. So the other thing, I use this all the time, which is I make graphs. And you can see in the A and B columns, I've got a time and a value. And, you know, this can be a CSV file. I've showed in a number of other videos how you can use CSV files and just drag and drop them into here. And you've got the time and the value, and you can go ahead and plot that. Now, What you have to do, and again, this can be kind of confusing. If you're going to do this where you've got time and value, you're going to need an XY scatter plot, not a regular time plot. You're going to need an XY scatter plot. So you will insert and a chart, and instead of a line chart, you will go to XY scatter, okay? And then you can pick something like this, which is smooth lines, and that's what I've got here. So again, it's kind of confusing, but if you want to use the time and the value, it's an XY scatter plot. So in this case, I wanted to plot just a simple sine wave, okay? So I've got this set up to automatically generate a sine wave, okay? So it fills in these values depending on what frequency I want, right? So all I have to do is in these yellow cells, I enter the frequency and the phase angle. And it automatically calculates what the values are for time and value, okay? Now, if you do that, you need to keep in mind that you need to have a sample rate. You need to generate a sample rate that is at least twice this frequency, okay? We all know about that, the Nyquist requirement. I do like 10 times, okay? So I've got a 10 times. So what it does, I enter the 60 and the 0, and then here I've got an equation which basically gives me 10 times this value, okay? And therefore I have a time step which is 1 over this, okay? 1 over 600, and that's the time step. So since I've defined the time step here, I know there needs to be this much time between each value in the time column. So I start out with 0, and then I add this value. So this becomes this previous value plus this, which is, if I always wanted to refer to this, I put a dollar sign, so $J, $3. So this is J3. So now I've got the equation to fill each one in. So now I just take this and copy the same equation, and it will fill in the correct time steps for each time step. And then what I do here, so now I've got all the time steps. Now what I've got is the value, and the value is this equation here. It's basically the sine equation, 2 times pi, so it's pi with a with parentheses. There's a function pi times G2, $G, $2, which is this frequency. So it's 2 pi f times time plus this value converted to radians. So radians times $G, $3. Okay, so I fill in this equation and then just take this plus sign at the bottom and just copy it to each subsequent cell, and it automatically calculates this, okay? So again, very nice to be able to do this kind of stuff, and then all I have to do is change the phase to, say, 45 degrees, and you can see it's now changed by 45 degrees, and go back to 0. I can change the frequency, 120, and there you go. So again, really nice. So you can basically, I've got complex numbers, I've got graphs, and I've got notes here. Now the other thing you can do is get kind of fancy with the graphs. Now this is something I'm preparing for a tutorial on calculating inductance values using signal generator. And you basically measure the frequency at which the voltage across the inductor is 50% of normal, and that helps you figure out how much inductance there is. So I can set up a spreadsheet here where it plots on a log-log curve what frequency you get for the 50% point, and that tells you right away what the inductance is. So again, it's kind of a bit of a mess when you do these graphs, but once you figure it out, it's not too bad. So for example, for this, if I want to change something about this graph, Again, this is an XY scatter plot because I've got frequency versus inductance. So what I do is I can select this chart, and you can see there's an outline here, and go up to Chart Tools and Layout. And that's the best way I've found to adjust things and vary them on your chart. And I'm not going to go into the details on this. This is basically just to get you familiar with that you can do that. But for example, let's say I want to have a different range of inductance values. I click on this and I right click and I can format the axis or the grid lines, change the chart type. I can do the same here. Click on this, right click. And I can also go into this layout and I can change the titles, I can change the legend, the labels. Again, this is a whole big project in learning all these things about the graphs, but just so you know that that's there, and it can be very useful, especially if you generate something like this and you can just go in and change values. So anyway, that's what I got for this video. Hope it helps. Take care and have a really good day. Thanks.